All right. What about inequalities that compare absolute values to negative numbers or zero? What if we have the absolute value of some expression is less than a negative number? Is there any way an absolute value can be less than a negative number? No, it's impossible. If we have an inequality that says an absolute value is less than a negative number, there is no solution. Same with an inequality that says an absolute value is less than or equal to a negative number, or an inequality that says that an absolute value is less than zero. Now, if we see an absolute value is less than or equal to zero, well, it's possible to get an absolute value that's equal to zero, isn't it? In this case, we have one solution, and that's where our expression equals zero. I'm going to show you an example of this. If I tell you the absolute value of 2x plus 4 is less than or equal to 0, that can only happen when 2x plus 4 is 0. So when 2x is negative 4, which happens when x is negative 2. In interval notation, if we want to express this, the right way is as just the set containing the one number 2. What about greater than? What if we have an inequality that tells us that an absolute value is greater than a negative number? Well, the absolute value of everything is either a positive number or 0, so it's always bigger than any negative number. In this case, we have all real numbers are solutions. Same with an absolute value is greater than or equal to a negative number, or an absolute value is greater than or equal to 0. Right? No matter what, everything's absolute value is a positive number or 0. It's greater than 0 or it's equal to 0. It's greater than every negative number. A little bit different is if we have an absolute value is strictly greater than 0. Right, most things are solutions here, but the number that makes the thing inside the absolute value exactly equal to 0 is not a solution to this inequality. So let's say we had the absolute value of 5x minus 10 is greater than 0. Well, we want to find what's not a solution. The point that's not a solution is where 5x minus 10 is 0. So where 5x is 10, and that happens when x is 2. Right, so x equals 2 is not a solution. If we just wanted to write this with an equation, we would say x is not 2. In set builder notation, we would say all x such that x is not 2. How would we write this in interval notation? On the number line, we want everything to the left of 2 and everything to the right of 2, but not 2 itself. In interval notation, we would write everything smaller than 2, union everything bigger than 2. If this were to come up in a problem, this is how we would write the solution in interval notation. Now, should you memorize everything on this list? No, you shouldn't memorize everything on this list. All of this is just applying what we know about absolute values. What you should do is be aware of this list so that when you come across an absolute value inequality in one of these forms, you aren't confused by it at all. You know how to understand it.